The science behind Godzilla, could he exist? Hey there, folks, ever watched a Godzilla movie and thought, wow, imagine if that giant lizard was real? I mean, who hasn't daydreamed about gigantic creatures roaming the earth, right? So today, let's dive into a fun question. Could a creature like Godzilla actually exist in our world? Godzilla isn't just any monster. He's the king of the monsters, a pop culture icon that's been smashing cities since the 1950s. But setting Hollywood aside for a moment, let's put on our scientist hats and explore whether Mother Nature could cook up something so colossal. First off, a little trip down memory lane. Godzilla first appeared in 1954, right in the heart of Japan. He wasn't just a cool monster, he was a symbol. Post-Hiroshima and Nagasaki, Japan was grappling with the devastating impacts of nuclear weapons. Godzilla emerged as a metaphor for nuclear destruction, a giant, unstoppable force awakened by humanity's own destructive technologies. Over the years, Godzilla has evolved. In some movies, he's a villain, in others, a hero. His size, powers, and even his motives have changed, reflecting the times and the fears of each generation. Whether in the classic Japanese films or the big-budget American remakes, Godzilla has been reimagined countless times, but one thing remains constant: he's huge. So, let's talk turkey, or rather, gigantic, prehistoric, possibly radioactive reptiles. Godzilla is typically depicted as being around 100 meters tall. That's like stacking over 30 elephants on top of each other. As for weight, estimates vary, but some put him at a staggering 90,000 tons. To put that into perspective, the blue whale, the largest animal currently on Earth, weighs about 200 tons. The largest dinosaur we know of, the Argentinosaurus, might have weighed around 100 tons. So Godzilla is, well, off the charts. He's got that massive tail, those sharp dorsal fins, and walks upright on two legs. Now, walking bipedally at that size introduces some serious structural challenges. Think about it. Can bones even support that kind of weight? And let's not forget his metabolism. A creature of that size would need an astronomical amount of energy just to get through the day. We're talking millions upon millions of calories daily. That's a lot of cheeseburgers. Alright, time to get a bit nerdy, but don't worry, we'll keep it light. Ever heard of the square cube law? It's a principle that says as a shape grows in size, its volume grows faster than its surface area. So, when animals get bigger, their bones and muscles need to disproportionately increase in strength to support the extra weight. That's why elephants have thick legs and mice have skinny ones. For Godzilla, his bones would need to be incredibly strong, like, made of some super dense material we don't even know about. Regular biological materials like bone and muscle just wouldn't cut it. And moving? Forget running or agile movements. Even walking would be energy intensive and slow. In the movies, Godzilla is often the result of nuclear radiation, a creature mutated to enormous size. In the real world, radiation does cause mutations, but not usually the "now I'm a giant monster" kind. Most radiation-induced mutations are harmful, often leading to cancers or genetic defects. There are examples of mutated animals in nature, but they don't gain superpowers. They're more likely to have health problems. So, the idea that radiation could cause a creature to grow to Godzilla's size is, well, pretty far-fetched. Radiation tends to damage DNA rather than enhance it. Beneficial mutations happen, but they're generally small and occur over many generations through natural selection, not instantaneous mega growth. Let's consider Earth's environment. Gravity plays a big role in how big an animal can get. On planets with lower gravity, larger creatures might be feasible because there's less force pulling them down. Our atmosphere also matters. In the time of the dinosaurs, the atmosphere was richer in oxygen, which supported larger life forms. However, even then, nothing came close to Godzilla's size. Then there's the habitat. What would Godzilla eat? Where would he live? An organism that large would need an entire ecosystem just to feed itself. The impact on the environment would be catastrophic, not to mention the footprints. Looking back at Earth's history, we've had some sizable critters. Dinosaurs like the Argentinosaurus were massive, stretching up to 30 meters long and weighing around 100 tons. They managed their size through specific adaptations: hollow bones to reduce weight, massive legs for support, and slow metabolisms. There were also megafauna like the woolly mammoth and giant ground sloth. But again, these guys were nowhere near Godzilla's size. These animals adapted over millions of years to their environments. Applying their adaptations to Godzilla helps us see the sheer improbability of his existence. Now, let's entertain some futuristic ideas. Genetic engineering has come a long way. We've cloned animals, edited genes, and even created glow-in-the-dark cats. But creating a gigantic creature from scratch? That's beyond our current capabilities. Growth hormones can influence size, but they have limits. An organism's size is constrained by its genetics and environmental factors. Pushing beyond those limits usually leads to health issues. Then there's synthetic biology, where scientists design life forms with specific traits. Cool stuff, but again, scaling up to Godzilla proportions is not something we're remotely close to achieving. Plus, there are ethical and safety concerns that would stop such experiments long before they started. One of Godzilla's coolest features is his atomic breath, that blue blast of energy that can level buildings. In nature, some creatures have impressive defense mechanisms. The bombardier beetle, for example, can shoot boiling hot chemicals from its abdomen to deter predators. But generating and projecting energy like Godzilla does? That would require an internal nuclear reactor. The energy needed would be astronomical. An organism simply couldn't generate, contain, and release that much energy without, well, self-destructing. Beyond the science, Godzilla serves as a powerful metaphor. He embodies the fears of nuclear warfare, environmental disasters, and humanity's often reckless relationship with nature and technology. Godzilla has influenced not just movies but also sparked discussions in science and ethics. He's been a subject in academic papers, debates, and has inspired countless other works in media and literature. His impact is colossal, pun intended. So, could Godzilla exist? Based on our current understanding of biology, physics, and environmental science, the answer is a resounding no. The challenges are just too great, from the structural limitations of supporting such mass to the metabolic demands and environmental impacts. But hey, that's okay. Part of what makes Godzilla so fascinating is that he pushes the boundaries of our imagination. He allows us to explore what-if scenarios that, while not scientifically plausible, are undeniably entertaining. So, there you have it, a casual dive into the science, or science fiction, behind Godzilla. What do you think? Did we burst the bubble, or is there still a part of you that thinks maybe, just maybe, there's a giant monster snoozing at the bottom of the ocean? Drop your thoughts in the comments below. And if there's another creature or concept you'd love to see us break down scientifically, let me know. Don't forget to hit that like button, share this video with your fellow monster enthusiasts, and subscribe for more fun explorations into the fantastical realms where science and imagination meet. Stay curious, everyone, and thanks for watching. Catch you in the next video.